Assalamualaikum and hello everyone! In this video, our group will be presented a topic about the application of linear algebra in food business. So, let's go through. The food industry is one type of the business which is a complex and global network that supplies most of the food that is consumed by the world's of population. In the terms of the food industry, it covers a series of the industrial activity that directly result in the production of foodstuff. The flow of it starts with production, distribution, processing, conservation, preparation, preservation, transport, certification, and packing of the foodstuff. Nowadays, the food industry is more challenging than what we see. There are too many people involved in the food industry business, and that makes the competitors among them more tight and hard. In this case study, sugar bakery store owners wanted to prevent his store from having problems in food wastage and store finances. This is because he has a manufacturer of dessert types food that are easy to spoil and lose their nutrients when left for a long time until expired. Three types of famous desserts such as red velvet cake, chocolate indulgent cake, double chocolate chip cookies are always produced in large quantities, so that there is a waste of food and money here. Finally, we agreed that to find a solution, we will be using Kramer-Rule's method in obtaining the correct production level. There are three reasons why we choose Kramer-Rule method. First, we want to have the owner of sugar bakery store to produce the right amount of production so that there is no wastage. Second, by applying Kramer-Rule, we can calculate the cost of producing cake and cookies at his shop since the matrix has a non-zero determinant where the coefficient matrix is non-singular. Third, we choose the Kramer-Rule because it is easy to use and apply, since we had done some research to find a suitable formula to use. Following that, in early February, the owner of Sugar Bakery store also conducted a test by raising the price of 1 ringgit for the three famous desserts to make a profit. However, there is a reduction in product sales for each of these foods. And at the end of February, in order to obtain the total sales revenue of the three foods for January and February, we made a calculation using the multiplication matrices method. Whereas the method of subtraction matrices, we use to calculate the profit or loss that he earns as the result of the modification of price increase and tax reduction.
Step 1, we assume that the red velvet cake, double chocolate chip cookies, and indulgence chocolate cake as X, Y, and Z. From all the information we get from the equation, we make the linear equation. For the first equation, we refer to the statement that the total production of these three items per week must be only 252 packs. The statement means that the first equation we get is X plus Y plus Z is equal to 252, which is X as the red velvet cake plus Y as the double chocolate chip cookies plus Z as the indulgence chocolate cakes is equal to 252. The second equation is negative X plus Z equal to 20. We gain the equation from the statement of the production of the indulgence chocolate cake exceed the production of the red velvet cake by 20. For the last equation, which are the third equation, is X minus 2Y plus Z is equal to 0. This equation refers to the statement that the total production of the red velvet cake plus the indulgence chocolate cake is twice the total production of double chocolate chip cookies. The next step is, after we recognize all the equations, we can see the equation that we form are simultaneous equation. In order to proceed solving this problem, we need to write the simultaneous equation into the augmented metric form first. The augmented metric form is a metric form AX equals to B. Therefore, we need to apply the Kramer-Rule method. But first thing first, before we apply the Kramer-Rule method, we need to find the coefficient metric from the linear equation or augmented matrix, which we had done before. After knowing the determinant for matrix A, we need to proceed by finding the determinant for each A1, A2, and A3, also by using the cofactor expansion. So, for the determinant of A1, we replace the column 1 with the matrix B, and lastly, we get the answer is 444. While for the A2, we replace the second column with matrix B, and we get the answer of 504. And lastly, for the A3, we replace the third column with matrix B, and the determinant we get 564. For the last step, we can use all the value that we gain from the Kramer-Rule formula to determine the total production of each item. So the Kramer-Rule formula is Xi equal to determinant of Ai divided by determinant of matrix A, where I is equal to 1, 2, and 3. So, how we get the X? First of all, we divide the determinant of A1 with matrix A, and we get X equal to 74. For Y, we divide determinant of A2 with matrix A, and Y we get 84. And lastly, for Z, we divide the determinant of A3 to determinant of matrix A and Z, we will get 94.
Based on the problem statement, the owner of the store already set the limit of 252 packs for the top 3 items to be produced in January in order to avoid any wastage in the production. The owner wanted to find out the total production of each one of the item based on that limit. Here, we can use the Kramer's rule to find out the total production of each item respectively. By applying the Kramer's rule, which also involves the determinant by using cofactor extension, we could know the exact total of each one item, which the Red Velvet Cake as X, double chocolate chip cookies as Y, and indulgent chocolate cake as Z, that should be produced during that month. Based on the solution to the problem that has been discussed, we managed to find the total production of each item by applying the Kramer's rule method. By using this method, we have determined that the total production of red velvet cake is 74 packs, double chocolate cookies is 84 packs, and for indulgent chocolate cake is 94 packs. Therefore, we have proven that we can find the total production of each top 3 famous desserts by using Kramer's rule method.
Now let's proceed to the second problem statement. Based on the following table, these are the total sales in January for each item with their selling price, which are M8 for a slice of red velvet and chocolate indulgent cake, while RM5 for a bag of double chocolate chip cookies. So the owner wanted to gain profit by increasing the selling price to RM1 for each of these items in the month of February. And as the result, the total sales for these 3 items has dropped. Here, we want to find whether the store will gain profit or suffer loss in between the January and February sales.
Okay, next is methodology. Step 1, we need to declare the information that we get from the problem statement in simple form. We let T as total, P as price, S for sale, R for profit, J represent January, and F represent February. Step 2, we convert the information given into the matrix form. Price of all items during January are put in the matrix PJ, while the price of all items in February are put in the matrix PF. Both matrices are row matrix with size 1 times 3. After that, we put the sale of each item in January in matrix SJ, while the sale of each item during February in matrix SF. Both matrices are called column matrix with the size 3 times 1. Step 3, by using multiplication of matrices, we determine the total sale in January and February respectively. We need to multiply matrix P with matrix S to get the total sale in particular month, which we name as matrix P. To get the total sale in January, we need to multiply matrix PJ with matrix SJ. Then, we need to multiply matrix PF with matrix SF to get the total sale in February. At the end of this step, we gain the total sale in January is 1,764 ringgit Malaysia, while the total sale in February is 1,656 ringgit Malaysia. And the last step is step 4. We need to find profit or loss for the items between total sale in January and February. So we apply the subtraction of matrices. We subtract total sale in February from the total sale in January. As you can see here, we use L to represent loss and L is equal to matrix PJ minus matrix PF. And this resulted us to get 108. Thus, the sugar category stores suffered a loss of 108 ringgit Malaysia when they increased the selling prices of each item by 1 ringgit Malaysia.
So, based on the solution, firstly, we could use the matrix multiplication to calculate the total sales for each month. Then, after we gain the total sales for both months, we can use the matrix subtraction to calculate the difference between the February and January sales. And at the end, we will know if the store will gain profit or suffer loss.
Next, I will continue our video with discussion of problem statement number 2. Based on the discussion that our group has done, we managed to know whether the sugar cakery store earned profit or loss. At the same time, we also managed to get the exact total profit or total loss that the store have earned. By applying multiplication of matrices and subtraction of matrices, we are able to solve this problem. By using this method, we have determined that the total loss that the sugar cakery store earned is total of 108 ringgit Malaysia. Thus, we have proven that we can get the total profit or total loss faced by the sugar cakery store in the 2 months by using multiplication of matrices and subtraction of matrices.
From all above, we can conclude that the application of linear algebra has helped the owner of the sugar cakery store to find out the total production of each item and determine the sale profit of the store. This demonstrates that understanding linear algebra also inspires us to seek out simpler ways to make our lives more efficient. Therefore, we have learned how to use the linear algebra to help us solve the daily life problems. Despite this, the application of linear algebra is extremely useful in our daily lives.